Hello, my name is Hannah Murray, and I'm a third-year PhD candidate in computer science at the University of Southern California. Today, I'm presenting a study we conducted as a proof of concept for how GeoAI can unveil new information into how illegal wildlife trade networks function. The illegal wildlife trade encompasses the illicit harvesting and selling of wildlife and their byproducts. Despite this being one of the leading causes of biodiversity loss, knowledge of the illegal wildlife trade is highly limited since there's such little reliable data. Organizations invested in understanding wildlife trafficking will quantify the scale and impact of the trade by aggregating counts of wildlife trafficking by country, species, or time period. This is a good entry point to understanding the trade, but the data exhibits multiple types of bias, as shown here. Combined, these biases make it such that the data cannot be used to make reliable inferences on what the trade looks like now or what it could look like in the future. Encoding where this trade occurs and decoding how the networks function are prerequisites to developing successful interdiction efforts. We used both centrality analysis and AI modeling as a first attempt to uncover where undetected hotspots are and why wildlife traffickers select the airports they do. Centrality analysis can identify key airports in the illegal wildlife trade. We hypothesize that the role an airport plays in the full flight network, representing all airports and flights around the globe, could give us clues into the role it plays in this sub-illegal wildlife trade network. We found that the more central an airport is in the full flight network, the more likely it was to be implicated in the illegal wildlife trade. We were excited by this result as it meant we could use features of the airports in the full flight network to make inferences on their involvement in the trade. Our next step was to build a model that predicts if each airport around the globe was involved in the trade. We considered features across 4 different categories. The first category, location, includes several centrality measures of the airports based on our prior slides' results. The other 3 come from an organization called the Global Initiative Against Transnational Organized Crime and their most recent crime report. And in this report, they score each location on the presence of different types of crime, as well as how resilient that location is to crime. These features were selected due to the substantial literature that's been published on the convergence of different types of illicit trade. Our AI test can be seen in this graphic. We have roughly 2,000 airports around the globe, and we know each airport's value for the features showcased on the last slide. We also know if those 2,000 airports have observed illegal wildlife trade incidents in our dataset. Using both of these pieces of information, we train an AI model such that it can predict the likelihood each airport participates in the trade. So what can this model actually tell us about the trade? Through prediction error and feature importance analysis, we can actually attempt to answer these 2 open questions discussed at the beginning. This graph shows us which features were most important in predicting if an airport was involved in the trade and will help us answer the question of why do wildlife traffickers select the airports they do. The 10 selected variables in our best performing model are on the y-axis, ordered from top to bottom on how influential they were in determining involvement in the trade. High values for the features in the location, criminal actors, and criminal markets categories increase likelihood of involvement in the trade, whereas high values for features in the resilience category decrease likelihood of involvement. The next open question was determining where these undetected hotspots of wildlife trafficking are. This map represents all locations our model incorrectly identified as being implicated in our dataset, despite them not actually having any reported incidents. The intensity of the red color corresponds to how confident the model was in its prediction, and there were 306 of these airports with varying degrees of confidence around the globe. Overall, this process showcases a proof of concept for how GeoAI could be used in this space, but we do plan to expand our methods. We are a part of a global initiative called Operation Pangolin, which aims to improve conservation outcomes for the most heavily trafficked species in the world. By unifying data from biomonitoring, criminology, and social ecological systems, using the key locations identified from these 3 pillars, we are exploring building a similar model that predicts the likelihood of involvement not only on airports, but on individual facilities located by local communities within this particular region. Thank you for your attention. I've included our contact information and details on Operation Pangolin here, as well as a link to our paper and an interactive map of our undetected hotspots. We are just scratching the surface of what AI can do, so please reach out if you're interested in learning more.